Question 8. The sketch below represents the curve of f of x, which is a cubic function, and it has a turning point at d, which is equals to minus 2 and 32. So that's the first turning point, and the gradient of the tangent at x equals to 3 is 15. So 8.1, we are asked to show that the value of a is equals to 1, b is equals to minus 12, and c is equals to 16. So we're going to use the given information. We're going to use the turning point. We're going to use the gradient of the tangent to find the value of a, b, and c. So the first thing we're going to do is we're going to write our f of x, which is equals to ax cubed plus bx plus c. And because we are given the turning point, which is minus 2 and 32, right? It is the point of d, right? So we have to derive this cubic function. So it's going to be 3ax squared plus b. Then we're going to substitute this turning point here. Where there's x, we're going to put minus 2. Where there's y, we're going to put 32. So then from here, we have the derivative. So we're going to equate the derivative to 0. So 0 is equals to 3ax squared plus b. And then we use the turning point, which is minus 2 and 32. So we're going to substitute the x value of the turning point, which is minus 2. So 0 is equals to 3a into minus 2 all squared plus b. So it's going to be equals to 0 is equals to 3a multiplied by 4 plus b. So it's going to be 3 is equals to 0 is equals to 12a plus b. So this is going to be your equation 1 for this problem here. So therefore we go back to our first derivative, which is equals to 3a x squared plus b, right? And we are told that the x value of the tangent is equals to 3, right? And we are told the gradient of the tangent, which is equals to 15. So we're going to substitute that. So instead of writing f prime x, you're going to write 15, which is the gradient. 3a, where there's x, we're going to put the value of the tangent plus b. So it's going to be 15 is equals to 3 squared is 9. So it's going to be 3a multiplied by 9 plus b, right? So it's going to be 15 is equals to 3 times 9 is 27. So it's going to be 27a plus b. So this would be your equation 2. So now you have equation 1 and equation 2, and you want to find the value of a and b. So you can use simultaneous to find the solutions here. So your equation 1 is equals to 0 is equals to 2. So your first equation, which is 0, is equals to 12a plus b. And your second equation, which is equals to 15, equals to 27a plus b. So this is equation 2. To write it properly, so you can write and equate to b both equations, this and this one. So starting with equation 1, we can say b is equals to 12a, and say maybe it's equation 3. And then this one here, we can say b is equals to 15 minus 27a. We can say it's equation 4. So if we equate equation 3 with equation 4, we're gonna get 12a is equals to 15 minus 27a. Then we transpose the 27a to the other side. We have 12a plus 27a is equals to 15. Then now So to equate our equations, starting with this equation 1, we're going to say b is equals to minus 12a. We can say this is equation 3, and this one here we can say b is equals to 15 minus 27a, which is equation 4. So we can simply say equation 3 is equals to equation 4. Equation 3 equals to equation 4. Equation 3, which is equals to minus 12a, equals to equation 4, which is equals to 15 minus 27a. Transpose 27a to the other side. We have minus 12a plus 27a equals to 15. Then minus 12a plus 27 is going to give you 15a, which is equals to 15. So divide by 15 both sides. We're going to get a being equals to 1. Remember that we said b is equals to minus 12a. So you're going to substitute the 1. So it's minus 12 into 1. So b is equals to minus 12. Then we need to find our value of c. So to find our value of c, we now have f of x equals to, remember our f of x equals to ax cubed plus bx plus c. So we already found the value of a and b. F of x is equals to, our a is 1, so it's x cubed. Our b is minus 12x plus c. So what we're going to do is we're going to substitute our point, our turning point of minus 2 and 32. So it's going to be 32 is equals to minus 2 cubed minus 12 minus 2 plus c. All right, so 32 is equals to 8, so it's going to be negative 8, and then 12 multiplied by 2 is going to be positive 24 plus c. Then we're going to transpose these two numbers to the other side. We're going to have 32 plus 8 minus 24 is equals to c. So therefore our c value is going to be equals to 16. 8.2.1, we must calculate the x coordinate of the point of inflection. So to find the point of inflection, we first need to define our f, which is x cubed minus 12x plus 16, right? So the point of inflection is the third derivative. So the first derivative of this problem here is going to be 3x squared minus 12. The second derivative is equals to 6x. So this defines the point of inflection. So to find the x coordinate of the point of inflection, you equate the second derivative to 0. So 0 is equals to 6x, then you divide by 6 both sides. X is equals to 0. So this is the x value of the point of inflection. 8.2.2, we are asked to determine the values of x for which the f is concave down. So if you take a look at this graph here, this portion is concave up. This portion here is concave down. So we're going to use the point of inflection to actually predict the concavity of this graph. So we know very well that the x value of the point of inflection is equal to 0, meaning it's somewhere here, right? So since the x value of the point of inflection is equals to 0, to define the concavity, concave down, it's x less than 0. So any value that is less than 0 will define the concavity of the function to be down. So it's going to be concave down. As you can see, in the diagram here, concave down is just below x less than 0. Anything below x equals, oh sorry, anything of x less than 0 will mean that it has a graph or the concavity facing downwards. 8.3 says that write down the coordinates of d prime, the image of d reflected about the x-axis. So this is the x-axis. So if you reflect anything about the x-axis, which means now if you reflect this d, which is this point here, about the x-axis, means now the graph will look something like this. Right, it's gonna be something like this. So where there was d there at that point, it's going to come here, which we call d prime. So the x value, because it's -2 here, it won't change, so it's still going to be -2. The only thing that will change is the y value, because it's at this point, which is 32. At this point now it's going to be -32, so meaning that d prime is going to be -32, like that. So that is the new image of d. Then 8.4 says that is f a function? Give a reason for your answer. So for us to prove that the graph of f is a function, we need to test it using the vertical line test. So if you were to test the vertical line test, x is equals to y in each and every point. X is equals to y. So if x is equals to y, then which means the graph passes through, like it passes the vertical line test. So what we can conclude is say yes, f is a function. Reason is f pass the vertical line test. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.